Hey everyone, welcome to today's video, and in this video today we are going to learn about a very interesting topic of digital electronics called the Karnaugh map. Now the Karnaugh map or the K map is very similar to a truth table because it presents all the possible values of input variables and the resulting output for each variable. So in this video we are going to concentrate on a 3-variable Karnaugh map. Now let us say we have 3 variables, that is A, B and C, and these 3 variables are to be represented on a Karnaugh map. So a 3-variable Karnaugh map will follow the rules of 2 raised to the power n, where n represents the number of inputs. So since here we have 3 inputs, so that means 2 raised to the power 3 becomes 8. So a 3-variable Karnaugh map will have an array of 8 squares. So let us draw the squares. So first of all we'll be going ahead with 8 squares. So let us draw one big giant rectangle and divide it into certain sections. So this is basically a Karnaugh map of 3 variables. So what happens here is that 2 of the variables, let us say if we have A, B and C, so C bar and C will come here, and then these vertical rows, in fact these 4 horizontal rows will have a combination of A bar, B bar, then we'll have A bar B, after that we will have AB, and last one would be AB bar. So as you can see that this entire array is now kind of bifurcated into different 8 segments. Now every single value of these of cell will have a certain value. So let me redraw this again with a bigger dimension, and then we can analyze what lies inside the cells. So this is 1, 2 and 3. So we'll go ahead with C bar and C. The first one would be A bar, B bar, then we'll have A bar B, then AB and AB bar. So the first cell basically is a cross link between this and this. So this would be A bar, B bar, C bar, and then this would be A bar, B bar coming from here and C coming from here. Similarly, this one would be A bar, B, C bar, and this cell is coming from this side. So this is A bar B, and then we write the column which is C. Similarly, for this one, we'll write the row first. So that is AB and the column that is C bar. For this one, we'll have AB and C. In the next one, we'll have A, B bar, C bar, and A, B bar, C. So as you can see now, the array is completely kind of filled. So what happens is that this shows a 3-variable Karnaugh map, and as seen it is an array of 8 squares. Now in this case A, B and C are used for the variables, although any other 3 letters could be used. Now the value of A and B along the left side and the values of C across the top, the value of the given square is the value of A, B at the left in the same row combined with that of the value of C in the top of the same column. Now for example, a square in the upper left corner has a value of this one A bar, B bar, C, and it shows that basically the product terms are represented by each square in the Karnaugh map. Now the Karnaugh map is very similar to the truth table because it presents all the possible values of the input variables and the resulting output for each value. However, instead of being organized into columns and rows like a truth table, the Karnaugh map basically is an array of squares or cells in which each square represents a binary value of the input variables. The squares are arranged in a way so that the simplification of the expression with 2, 3, 4 and 5 variable Karnaugh maps it becomes easy. Now basically 5 variable Karnaugh maps are pretty difficult to kind of manage and explain. So for higher number of variables, another method which is called the Quine-McCloskey method. So the Quine-McCloskey method is basically used for all the variables above 5 method, and the number of squares in a Karnaugh map is equal to the total number of possible input variables combinations. For 2 variables, the number of squares is 2 raised to the power 2. For 3, it is 2 raised to the power 3. And let us say if we have a 4-variable Karnaugh map, that would be 2 raised to the power 4, that is 16. So I hope that this video was informative enough, and for more such videos, don't forget to subscribe to our YouTube channel. Thank you so much for watching.